Okay, hello. Welcome back. I hope I am live. Not quite sure though. Twitch is on. YouTube a little late, but yeah, seems like it's lagging behind a little, as usual. Yeah, but seems good. Everything seems to be running. Oh, this would seem so. Okay, Twitch complaining that the stream is unstable. That's great. Haven't seen that in a while. What's wrong with it? Okay, but I think it's still streaming okay. Okay, I think it's fine. Can't really tell. Anyways, welcome back to the stream. Today we have a Monday, as usual, a lot of work to do. But before we start, a quick update from our last stream on Friday, where we were building my prototype. That didn't really work in the end, after 3 hours. And so it happened that I had to replace the resistors. I had to swap the 1/8 of a watt. I had to change to 1/4, if I get it correctly. And I think I had to swap one diode because it was fried. And after that, it worked fine. My junky idea with adding those potentiometers kind of worked. There is a possibility. It's still better than just like one resistor. So the keyboard works fine. I think I can even show it to you. I hope I won't kill the stream with that. Maybe half by half. So there it is. Quite a beauty. I think it's my favorite keyboard so far. My favorite prototype, actually. Of course, there had to be some junk. I don't know if you can see maybe from the top. Yeah, the harness for the potentiometer was kind of loose. So I just put some paper in, so it holds. Didn't really make sense to do anything else with it because this encoder will be gone anyway. So this is just a temporary solution. So yeah, this is the right side. It's quite okay. We have infrared over here, works great. And if I hold it like that, as you can see, here's the potentiometer and you can adjust. It works great. And here is the left side. We have the volume and we have two infrared and of course two potentiometers to adjust. One is over here and the other one is here. So actually it took me so much time that I could easily make one more episode out of it, because I think I was doing this on Saturday. I think it took me like 3 or 4 hours more before I finished everything. So, and there is still, of course, there's an issue. But I didn't want to reprint anymore. So as you can see, I am missing the column here for the screw. And there is like a big hole over here. I was worried that the screw might like just go through, but it didn't. Luckily it stopped. But as there is no support, the whole thing can like bend inside. And of course there's supposed to be a wall over here. Somehow it's gone. I don't know what happened, but I guess it's fine. Has to do for a while like that. So now I will try to plug it back in. I hope I won't kill the stream. It's always a risky procedure doing such things live. And the good thing is that it seems that my USB-C design kind of works even without hot glue. Okay, it's back on. Okay, so the stream is still running. So I guess we are good. Okay, cool. Okay, back to our table. Maybe we can do like a split view, so you have a better orientation what's happening. So as I promised, I was waiting on these little fellas. These are the mouse encoders that I have purchased some time ago. I was waiting for the arrival, and they did ship just last week while we are still building the prototype. So today, as promised, we are back to Chordie, and we're gonna be exploring the beautiful world of encoders and how to mount them. And I have to say I am kind of confused because I did some work over the weekend, and I was trying to come up with some idea how to mount it. So these are our old ones. Actually, this one was our top pick recently. And this one was for the volume, but I wasn't quite happy with the height of it. So that's why I am trying to pursue something that is lower profile. We also had this little fella. That one was quite okay, but it seems to be more suitable for a PCB because it's the only way to mount it without any wobble is to having it soldered down to a PCB. And another issue is that it's very difficult to find a decent knob for it. So this one is kind of like a no-go, I would say, which is a bit disappointing because it's the height of it is very promising. Then we have this. Initially I said we won't be bothering with this because it adds the complexity. So this is the magnetic field rotation detector. So when you put a magnet on top of it and rotate it, it can read the rotation of the magnet and it can output it. You can read it via I2C interface. And it also has some kind of a PWM output that kind of encodes the angle of the rotation. I haven't figured this one out yet, but even for my build, I don't think it's feasible to use because I would need an additional controller to read that. Or the best would be to have a similar output like we have from these encoders, so like ABC, or maybe just like AB output, and then on AB you have the reading which switch is on. Yeah, so initially I said this one is like a no-go, but it's kind of tempting looking at how tall is it. And I was even thinking maybe at some point we could do hand wire. I know it's kind of small, but I think it should be possible to hand wire, maybe. There isn't many components that are required to make it work. So this might be interesting. But the topic of today is this. The mouse encoders. I bought a bunch of them. I think I have most of the sizes starting from 11 millimeters, and I think 11 is this one. Yeah, it even says so on the chassis over here. It's 11 all the way to 16. So they are very soft compared to these ones. These ones are kind of difficult to rotate, whereas these, they are very soft. But here's the problem. We don't really have a lot of knobs to connect, to attach. Well, what you can do, you can buy a mouse wheel and then you can try to attach it somehow. So you can have it like this, for example, in your build, and then you attach the wheel, and then you need to support it somehow over here, and that's kind of it. It's not bad. We could have it like this in our build. The encoder could go from the bottom it has these fins that most probably we could just bend and lock it in place. Oh, we have pins, of course. And for example, then, like for our build, like this one over here that we are exploring some time ago, it could go like this. Well, actually, this one is kind of too tall. Okay, maybe we can go with the smaller one. Yeah, so this one is 11. I need to check later if they're even smaller than that. Maybe we could go with it. Yeah, so something like this maybe. But I have to say, it doesn't really satisfy me. So what I wanted to do, I would like to have it like this. I would like to have the encoder flat and have something like this. So we can rotate like a clock. And I want it this way because when you try to rotate in this position, so you can only go in like small steps like this. So you rotate and you have to go back, rotate and you have to go back. But if you have it flat like this, so you can technically have like an infinite scroll. And I think it would be better, and this will be also better for the height of the whole build, because if you have the encoder like this, it's gonna be it's not gonna take a lot of space. And I think it even fits within, yeah, it almost fits within one key space that is like 1905 by 1905. Well, I think it's a little bit over it. Yeah, but that's fine. But the issue is we don't really have a lot of knobs to use with it. We have this mouse knob, and this one is not that good actually. I mean, we can't really use it like that. And then there are almost no other options. So what I was trying to do, I started some... Oh, guten Tag, Ruda Brody. Guten Tag. Willkommen. Ja, is das richtig? Is it good to say like that? Is it okay? Willkommen. Well, good to have you on the stream. Just in case Yes, cool. Okay. So, mein Deutsch still... No. Good. That's all I can say. Okay, so going back to the topic. So today we'll be trying to figure out how to make a good knob for this encoder, how to mount it. I tried some designs already. So the biggest issue is the shaft, which is very thin. I think this one is 2 millimeters, and actually it's not even 2 millimeters round, because it's something like a hex. Just a quick... Yeah, so it looks more or less like this. So as you can see, I did 2.1, but sadly it turned out to be too thick. It doesn't really fit. And 2.0 was too thin, so I have to redo one more. I think I will do 2.05, and that is very easy to make. I can show you later. Yeah, but so the hole is like 2.1, but actually, as you can see, there isn't much space here, so it's not a full circle. So it makes the whole thing even thinner. And additional issue is that I don't have a 0.2 nozzle for my bamboo printer. I only have 0.4. With the 0.2, it would have been much better, I assume. And of course, there is still this encoder that I showed you some time ago. Let me quickly find it. It should be somewhere over here. I'm pretty much sure I saved it. Or maybe I didn't. Okay, oh, damn it. Okay, I can quickly find it on one of the streams. Just give me a sec. Because I think I posted a link to it somewhere. Okay, so that's the one. And this one is very cool. I like the design and I like the level of polish that it has. But I don't think I'll be using it, mostly because I would like to go with the horizontal layout, and this one is vertical, as you can see. Yeah, but it's done really, really well. Stunning piece of work. And I think I saw a store, Ergo Mech Store. I think they're from Vietnam. Yeah, and they also, I think they blogged about it, that they will be switching from, yes, the roller encoder is dead, long live the roller encoder. So yeah, they talk about the same design. So they will be moving to this instead of the old one, this EVG, EVQ, yeah. This one was super expensive, $30. Yeah, and when it started, it was $7. I still remember paying like this much. I do have quite a lot of them lying around, but you know, now it doesn't really change much if I want to have a compatible keyboard. So yeah, this one is nice. It's very good. Yeah, very small. Also, they found a different one even. Yeah, yeah, it's great what people are doing. Usually you can find cool stuff on Reddit, Ergo Mech keyboards. I think the craziest things people post there. So going back to our workbench, I was trying to come up with some idea how to create a knob, how to create a mount for it. I don't have the mount yet, but we can do it today. So I have something like a knob. This one turned out to be a little too loose, because if I pull it out a little, it doesn't really rotate anymore. It has to go like all the way in. It's just too thin. Besides, well, even for such a thin print, this one is 2.0. It still kind of holds well. I think this PLA is very good, in my opinion. So then I was trying to come up with something like this, to have a bearing inside. So it would look like this. We have there's the bearing. There was supposed to be, it should go from like the bottom plate, and just the bearing is meant to allow for the rotation of this, and then this will propel the shaft, and the encoder will be somewhere at the bottom, but I print this one too thin. So basically there's the design with the bearing. Yeah, so it's my idea was to do it like this. So we still need the bottom plate. Let me just quickly do like a mock-up. Yeah, so let's say that's the bottom plate. Maybe I can cut it in a convenient way. Okay, so something like this. But the thing is that actually, okay, I need to chop off a few things because this not supposed to be part of. Let's remove this. Actually, no. Let's do it like that. Because I need that from the bottom, and now I can remove it. Now let's do 1.2 below. Okay, I hope this will be like a good. Okay, and one more thing, so that it doesn't. Let's move this a little, maybe. Let's do it like 0.6 maybe, so that it looks okay on the section, like this. No, it doesn't look good on the section yet. Okay, let's just move it like, I don't know, 1 point, okay, minus 2.4, because I think I moved it the wrong way, as usual. Okay, maybe let's do it from this. I want to have it like 1.2. Okay, 1.4, okay. Let's leave like a small gap. Yeah, so my idea was to have it like this. And of course, inside there's the bearing. Let's do the bearing as well. Let's say 0.1 from here, and also minus 0.1 from here. Maybe I can change the color to something that would better represent that it's a bearing. How do I change the color here? Okay. Let's make it like this. Does it look metallic or not? Okay. So now we can do the section. Yeah, so we have the outer part of the bearing and the inner part that can rotate. So this can, then we can have the knob on top and rotate. So this is one part that will be rotating the top. I mean the outer side, and then we have the inner side that will be sitting on the shaft that I have just created. So this is our shaft for the bearing, this part. And then over here we'll have the encoder. So yeah, I was thinking maybe this would be like a good solution, because with the bearing there should be almost no resistance when rotating around. And also if you have it like this, there will be almost no force pressing on the shaft that goes on this one, that goes to the encoder, because everything will be sitting on the bearing. And this way I hope this won't break that easily, unless maybe if we do like a very quick turn left and right. But it shouldn't, because the encoder is very soft. It doesn't really have much resistance compared to the other ones. So maybe it will work. So how about we try to print that? And we still have to fix the shaft. So we have shaft 2 millimeters and 2.1, and neither of them was okay. So let's do 205. Okay, maybe I can just hide this. I was surprised how easy it is. Of course, now when I want to show it, most probably it won't work. Well, that's fine. So we start with the circle, so we want 205. So then I would just need to change that to the construction line. Then I want to go to the line, because if you look at this encoder, if we go AliExpress quickly, those them ads. Let's see, mouse encoders. Okay, these are from Kyle. Where are these? I think these ones. I think there was some kind of a drawing how to do it. Yeah, but like good luck finding the same auction now with the same drawings. But I assume it's the same, it's standardized, I assume. So maybe, or maybe it's this one. Oh, not what I wanted. Oh yeah, okay. Do we have a good drawing somewhere? Okay, 1.73. So it doesn't really. There was a different one. It was very easy to make the same dimensions. Okay, so it's 1.74, and you just need to do like 1, 2, 3, 4, 5. It's a 6 angle, 6 hex. Well, anyway, if we go back to the CAD, so this is kind of easy to do. We just take a line. We make a line that goes beyond the circle that we just made. We turn it into the construction. Then I want to move it. I will anchor here. And I just need to do create patterns. And now I'll just rotate. And we change the count to 6 and the angle to 60. Oh, not this one. This one is supposed to be 60. Yeah. So the angle between those lines needs to be 60. And now we can just make a new line, disable snap to grid, and go like this. And it's done. Nice and easy. Okay, so this is 205. So now I can pull this shaft. I don't know, let's make it 10 for now. And let's take a look at our design. Okay, that's the ball. We don't want that. Okay, so I guess I have to move it a little. Okay, so this is how it's gonna look like, and then we will have the bearing inside, like this. And then comes the bottom part with the shaft. Can I make it transparent? Yeah, so yeah, the shaft is embedded into the bottom part. So I was wondering if this is gonna work, because in my opinion, this would kind of make it put a little stress on the shaft on this one. Okay, maybe you can try to print it. I'm pretty much sure I missed something and it's not gonna print well. Okay, so this is our bottom part. I mean the knob part. Okay, looks good. Maybe I will just extend a little by another 10 maybe. Okay, and this is the bottom part, minus the shaft, of course. Yeah, so the bearing will be like sitting on top of it, like so. And the shaft will go through, like here. I also ordered some bearings, different sizes. They should arrive maybe this week. So I will have some more bearings, more sizes to test, because this one is, I think I bought like the standard one that goes into the skates, roller skates. So this one is like 22 or something like that. The radius is 11, so it's gonna be like 22, 21 point something. Well, actually, it's not about design. These are also easily available, like any sports shop should have it. So yeah, and yeah, you could even get like ones with less friction maybe. Yeah, but anyway, let's get to printing. So let's do this part first. Let's call it bottom. And our knob and the shaft like this. Okay. So now we need to jump into the Bamboo Studio quickly. Oh, as usual, new configuration. No, thank you. Not on the stream. Okay, let's flip this over. And the auto arrange. Okay, should be good for now. And off you go. Luckily, no issues with the printer today as well. Seems like the connection is good. I think the reason for it disconnecting was that there might have been some noise on one of the Wi-Fi channels. I just changed the channel to something different and haven't had any issues since then. So maybe we'll be good for some time. Okay, let's have a pop-up from our print. I think there is nothing left on the build plate from my previous prints. So I think I can leave it like that. Yeah, also, other than that, I don't really have any better idea than this one, this encoder. I mean, as long as I'm okay with going with the vertical one, I still would rather have something that is flat, so like laying flat. If you have a better idea how to mount one of these like this, and how to have it connect with a knob and not destroy the shaft, which will be very thin. I also noticed that M2 screw kind of fits in and locks in, but it's kind of wobbly at the same time. We might, okay, it's a little bit too late. I should have created one more knob with a screw opening in it. Well, I can do it now, and maybe for the next print we can add it. Yeah, so I noticed that instead of using a shaft like this, 3D printed one, we can actually do, we can use a screw that is M2 size. So let's make this knob with shaft and move it here, and let's make a new knob with M2 screw like this. So what I can do, I can just copy and paste. And then, so with our bottom plate, actually the screw can go from the bottom. So this will be the head, and the screw will go like this. And then we can attach it. I mean, we can make an opening somewhere, like over here. Let's make, so it should be 1.9 for the screw. And then let's make like, can we do 2.4? No, so 2.1. Okay, so 2.1 will be just enough to fit inside. Yeah, so the screw will go like here, like this. So this will be the head of the screw. it will screw into this column. And actually it will be holding like from the bottom, so then we won't have any hole over here. It will just screw in from the bottom. Like this. Yeah, this is also an option, but I noticed that it was a little bit wobbly. It didn't really go in. I have also ordered some 2mm bearing dowels. So these are like cylindrical small metal cylinders. And these are used to mount the bearings on them. So I was hoping that maybe we can push one through the encoder where the shaft goes in. And if it's too tight, I was even thinking maybe we can just heat up the dowel and just press it when it's hot, melt the inside, and then just leave it. So it would kind of solidify with the encoder. And maybe this will be like a good idea. But then, of course, there's an issue with the knob, because the knob might, after some time, might start like turning around the dowel because there is no thread or anything to hold it. And of course, yes, Rudo Brother will say just use glue, and this is a completely valid point. Yeah, but difficult to figure out something that makes sense at this moment. So we have to wait for the print to finish to validate our design, which most probably is flawed and won't work at all, but that's fine. Let me export this one as well. So this one is for the hole. Yeah, so of course, yes, glue rules. Yes, I know, I totally agree. A lot of my builds were saved by hot glue, so I can't complain. Let's take a quick look at our design before we even export it. Yeah, so it looks okay. I mean, it doesn't seem like there will be anything blocking it. So we have the bearing over here, the knob, and this is the opening for the screw. Well, actually, I can make it a little bit longer even, all the way to the bottom of our bottom plate, like so. Yeah, like this. It should be good. So it will be more space for the screw to go in. Yeah, and I still don't have a model for the encoders yet. Something that will contain it. Yeah, so but the shape is not that much complicated, actually. Maybe we can get away with just a simple rectangle and something to hold this. In place. But actually, if we put it like from the bottom, so you don't really have to worry much about it like moving, and just block the rotation so it doesn't rotate with the knob. Let's take a look at AliExpress if they have anything meaningful to show us. So that one was 11mm. Is it the same brand? No, TTC. So it's something different. Maybe if I check for TTC. This one looks kind of familiar. Okay. Yeah, I think I bought it from here. Yeah, they definitely should be good for a mouse. Yeah, but we don't really have much of dimensions. So this is 13. Yeah, if I could get a magnetic encoder with this kind of output, like you get like AC, BC off on like a normal encoder, so you have like a fixed number of pulses and dents. That would be awesome without having like a additional controller to do that. That would be great. Okay, if we seems like this dimension is related to the size, so I assume mine will be, this will be 11 plus minus 0.1. And is it like the thickness is the same? Because this one looks like it was just fixed with a pen before they scan it. Okay, maybe we can take a look on the bench. What are the dimensions? Like if it's the same width. Yeah, 11. No, it's 10.6 actually. And this is the same. They say 11.6 plus minus 0.3. Oh no, this is, okay, this is between the legs. Okay, yeah, so 11. Yeah, that makes sense. And yeah, and this is like 10.4 plus minus 0.3. Yeah, so yeah, that is correct. So it seems like most of the dimensions are the same, except for the height. So the height is from this part to here should be 13. How am I? 14. Yeah, this is 11. Sorry. Let's get one that is 13. So we have the same. Okay, so this is 13. And they say from the bottom to the middle of the shaft should be about, yeah, 13. I am not that much accurate. It's just like eyeballing it right now. Yeah, but it seems about right. Okay, so that is actually quite good. We know that the only dimension that is changing is this one, is the height. Okay, let's jump back to the CAD quickly. And let's make mouse encoder, sorry, mouse encoder, and let's make the 11 millimeters one. Where did it go? I think I dropped it here. Let's put it here. All right, so how does it look like? So we have our 11 millimeters. So we know that the width is 10.4. Sorry, the width 10.4, and this will be let's make 11.1. So maybe this one let's add 0.1 just to make it fit. Then there is one more part that seems to be fixed. 4 millimeters plus minus 0.2. Okay, so the legs. So we have this. We have this part done already. So now come the legs. So this is 3.5 millimeters, and they say that it's 11.6. But I think I would just leave it the same size as the rest of the encoder. So I want those legs to kind of like clip in. So maybe we can make some small openings for them. So they will just go in. Something similar to what we did with this encoder, if you remember. With this one. So we had the bottom, we had those legs kind of lock in. But for this one, it was better to just attach the screw. Okay, so let's make one more segment. Let's make it 3.5, as they say. And these look like this the angle over here, this part seems like it's like in the middle. So maybe we can do like an opening, maybe 1.2 or something like that. Okay, so what is the thickness of this thing? .5 for this one. I think all of them are the same. Yeah, 3.5. And this is 5.5. 5.01. Okay. I see that the print just finished. I will just pick it up, and in the meantime we can start this other print with the one with the screw. Okay, so we have fresh junk straight out of the oven. Let's do the other one. In the meantime, I don't think I exported that. It looks like it wants to. Oh, I don't need a tile maps, and don't need. Why is it even on? Okay, should be faster now. Okay, where were we? We are here, and our surface, it was supposed to be inside over here. Okay, so we were looking at the thickness, so it was 5.1, let's make it. Okay, so over here, our bottom, oh, that's not much space actually for it. If I do 1.2 and 1.2 like this, so this is where the legs will go in. Well, actually, the legs will be like over here, but I want them to, we'll just make an opening over here so that those legs will just go through. Okay, so we want to cut this, and we would like to thicken this one, like so. And now over here, let's make a rectangle from the center. So let's make it 1.2, maybe 1.6. Okay. And it snapped like that. Okay, how thick are those legs actually? It doesn't really say much. Okay, 2 point. So it's like, don't quite understand. 2 minus 195 plus minus 1. So it's gonna be, or maybe it says, okay, it's a 2 times 195, if I get it correctly. Okay, so if you wrap it around, this should be okay, more or less. One more look. So the thickness here is 3.6. If you look at it, yeah, 3.6. And this metal part is 5.2. Okay, so this one is 3.6 and this one is the same. This is the shaft, 6 times 60, so that's exactly what I showed you before. Okay, let's try and make a chassis for it. I will just copy these walls. Okay, so we have like the bottom already. So like the main part will go here, like so. And then we have those legs over here. I think I can just copy this element and rotate by 180. Okay, I can't. I did it wrong. Okay, now it's okay. Well, it would seem so. This should kind of fit. Most probably it won't. Well, you can adjust later. And okay, let's add the shaft. So it seems like the shaft is exactly over here. So it's like 4 millimeters from the top. So it should be exactly here. So we made it 205. Well, let's make it 2.1 because I think it will be okay to have some space left. So if you look at it, so my idea was something like this. Let me just align with the opening over here. Okay, let's assume it's gonna fit. So I will just leave this wall all the way up to this. So then we can test it with this print that we already made. Yeah, so if you look at it now, let's do the bearing and let's do the one with the screw for the shaft. Yeah, so this is where the encoder will be sitting over here. The legs will be here. That should kind of lock. And then we can have a screw all the way from the bottom to here. So this will be the head and this will be the end of the screw. We have bearing over here and our super fancy knob. Okay, and now I'm very curious. I hope it's gonna fit. That would be a very cool thing to try. Not quite sure if I spelled harness correctly. Oh well, who cares? Okay, so I will just do this this print in the meantime. Okay, let me go and grab the print that we just did. I'll be right back. Okay, so it looks like this. Not bad. Okay, I need a magnet to take it off. But first, let's send the print. Okay, I'll be right back. Just remove the bearing. Okay, I managed to get it out. I also broke the shaft in the process, but that was okay, because that one wasn't really working for us. So what do we have here? Okay. I should have made, okay, first issue already. I should have made something to raise it up a little because it's actually sitting on the plate. How do I miss such obvious things? I don't know. I guess it's fine. Okay, so this is how I envision it. Okay, and our shaft also fits. The one that is 2.05. Okay, and how does it look like? Oh, definitely the wheel has to be bigger. Or maybe something easier to rotate. Because there is nothing actually to grab it. And I think it's also partially because this middle layer is kind of blocking it anyway. Yeah, but I'm surprised that the shaft fits perfectly actually. I have nothing to hold it right now. Yeah, definitely we need some spacing over here. Maybe I can use a screw from the encoder, from this one. It won't fit. Okay, back to the drawing board as usual. Let's make a plane, so it will be easier for me to find the correct size, like so. I still have to measure it, I'm afraid. And that's gonna be tricky. It's 1.5. Well, we can call it 1.6. Okay, 1 second. So we have to make one that will span from this edge, 1.6. So we go to this edge. Actually, okay, one more try. So from here to here and 1.6. And of course we still need this opening. So we can make it 1.4. Okay, I move it all the way to the bottom, and this should give us some space. So now the bearing will be sitting a little bit higher. Okay, like so. So we have this. So this part should be resting on this razor that we just made, and this is the other side that is rotating, so this should prevent it from like rubbing on the bottom plate on this. So we have this razor over here. When it goes like this, it should be a little bit higher, like so, and then it should rotate fairly, I hope. How does our knobs look like? So this is our shaft one, and this one is for the screw. I can move it actually because we moved it up a little, so we can just add some space. Let's take a look on the section. Yeah, so I am hoping that this will help. So we have from the center, I mean from the edge, it's like 1.6. So this should give it some distance over here, like so. Yeah. Okay, that one just finished. I will just bring it, and we can sand this one again. Okay, so I'm back, and we have this one. Okay, let's go back to bamboo and just quickly send this new. I forgot to export as usual. So I want to send this bottom plate right now. Okay, and slice and print. But actually, we can make this part a little bit bigger. Because the inner diameter is like 7.9, 7.85, and I did it 2.7. That's like 5.4. So that's kind of okay. The outer 3.9, so it's a 7.8. Okay, so it's kind of should be a little bit bigger in my opinion. Let's make it 7.85 by 2. Okay, 393. I'm not quite sure if it's gonna make a lot of difference. What I would like to have is the bearing to sit tight on this. Okay, it hasn't started yet. So maybe I will just swap. Let me quickly check the printer. Okay, seems like the printer is fine, so it can print in peace for now. Okay, let's see what have we done with this design. No way, it looks like it's gonna fit, almost. So these are these, maybe I can push it. Okay, but I bent everything. So it has this fancy, there's this thing sticking out. So I didn't encode that. Well, actually it doesn't really bother us this much, at least for now, because all I wanted is for it to sit tight. So now when I try to rotate, it won't rotate because it sits. So basically we don't really have to do much about it. Yeah, but I would definitely include this later on. I just need to check on the schematic, on the diagram if there's a proper dimension for it. Most probably there isn't, but we can figure this out. Yeah, but this one sits, so it's okay. This one sits on this, and so we can have almost fully working design, almost. So we have the shaft. You can see it kind of aligns. So we just have to wait for this part to reprint. Okay, I will leave this one. So this one's definitely too small. I think the one that we just tried some time ago, the 32 millimeters and the bigger ones even. So that would be more feasible. Although, once we get it like fully working, maybe that would be enough. I just need to wait a little while. So we won't be needing this. I'm gonna focus on this one. Yeah, 11 millimeters should be fine. Okay, let's go back. Because I think I saw on AliExpress, I think Kyle had even smaller ones. I think they had even like 5 millimeters. Let's take a look. Yeah, they have even 5 millimeters. Oh, that is super small. Maybe I should order some like 5, 7, 8, 9. I had these before, but I threw them away. So my bad. Now I have to reorder again and wait. Okay, so where are we? Okay, 4 minutes left. We can have a drink. Rudder body still here, going for work today. Oh, that's great. I wish I had a day off. Oh, today I have a day off. Yeah, that's a good life. That's a good life for the Brody. I envy you. Oh, this 5 millimeters could be really tiny. It will definitely fit inside. Like, I think the 9 millimeters should be the best to fit inside the one switch size, probably. Let's take a look what we have now. So this is more or less one key. Okay, this is kind of big. Anyway, still kind of a little sticking out if you want to have it in the center. So it's taking a little bit of space. Yeah, but the 5 millimeters I should definitely order and check. That might be a good idea. It's a pity I didn't notice them earlier. I just bought these, and I don't think they had. I don't think they had such a small ones. Yeah, the small. Oh no, they do have 5 millimeters. Okay. Oh, this is super tiny. This might actually work. So I think I ordered from a different shop. The one that I ordered, I can't remember if they had such a small ones. Yeah, but I can order from here later. So I guess 5 and 7. No point. I don't think it makes sense to go with 9 because we already have 11. I don't know. Okay, print almost done. Okay, and it finished. I'll be right back. Try to rip it off the print bed. Okay, should have let it cool down a little, but no time for that. Okay, let's take a look now. Okay, it still doesn't really lock in. It should lock in, but it doesn't. And there's some space. Okay, let's take a look. Oh, damn it, the shaft won't go through. But I made it a little bit bigger. Or it doesn't go. Oh, it does go through the... Is it not aligned? No, it is aligned. Oh no, god damn it. Yeah, it's blocking. Okay. That's fine. Okay, I'll be right back. I need to remove this. Well, actually, I have another bearing. Let's measure. Okay, it says 7.92. So I have to, maybe I should make it 7.9. So now we have 2 more parts to print. So 7.9 by 2, 395. Okay, if it says so. And then it's 2.1. Okay, so let's make it 2.2. Okay, 2.5. Okay, a little bit too big. 2.2 should be good. Plenty of space. Okay, while we are at it, maybe we can take a look at this part and try to figure out where is it actually. They don't really show that. So this is only the size for this, and the whole dimension 501. Not sure what's that actually. Okay, let's take a look. So is it different? Yeah, it's longer for the bigger one. And we can make this groove. But how deep? Well, it seems to be in the center of the encoder. And how thick is it? 0.8. 0.8009. So we can make it 1 millimeter. Just to be on the safe side. And how deep is it? That's a good question. It's gonna be difficult to measure because it's so tiny. It says 0.35. Let's call it 2.3. 0.3, I mean. Oh, let's make it 0.4, a little bit more space. Okay, like so. Well, actually, it should be sticking out. Like so. And then we can cut it out from the harness. Okay, perfect. Okay, so let's export this one. And our bottom plate with the fixed bearing holder. And back to bamboo again. I wonder if it can print like this. If I enable support, is it gonna make a support over there? Most probably not. And there's no way actually to make a support. Okay, we see what happens. It looks like the print gonna take some time, 14 minutes. So we don't really have much to do with this at the moment. This one doesn't really fit. I'm surprised that the shaft doesn't go through. Should be, and damn it, and I broke the shaft. There it is. Yeah, that's the fragility. And now I have nothing to... I guess I have to stop another print. Okay, before it even started. Oh well, I always have to break things or lose something. Yeah, so this part definitely has to be fixed in place. So then it will be quite nice to rotate. What is the printer doing? Nothing at the moment. That's great. Exactly what I needed. 17 minutes. Okay, I guess with the print going so long, I know, Rudobrode, shall we wait for the print to finish and see the final result for today? Or should we call it the day? What's your take on that? Curious if it fits? Do it. Okay, sure. I have the smaller shaft over here, and this one will probably go through. Oh no, also not really. Barely, but this one didn't really work. Didn't really rotate, yeah. Junk as well. Okay, this we have a screw. Okay, I will go and bring the screw, and we can check with the screw if there's any difference. I have a M2, and this one is 12 millimeters. Oh, let's go for 14, maybe. The longer, the better. Okay, screw doesn't really go through as well. Okay, so this is too tight, definitely. It's not gonna do its job. So goodbye, trash. Okay, so I have this. Okay, I will go and try to take this bearing out with the magnets. I'll be right back. That was kind of easy. I have also mastered the dark arts of desoldering pin headers, because for the prototype that we built last Friday and that I have finished over the weekend, I managed to desolder one more mouse sensor from AliExpress with all those stupid pins that we did in one of the very first few streams. So now I'm a pro. It took me like 30 seconds maybe. So yeah, that was a good lesson actually. Well, I guess this one's also trash because we didn't, this one doesn't really fit anyway. Good that I brought the trash today. And this one is also trash. Oh, so much trash today. And this one is also trash. Most of the stuff that I printed ended up in trash. And this is trash as well. Okay. So we have like 10 minutes left. This one is very tempting. Like if you take a look, yeah, a little bit big. But we could have the magnet inside like this. So the magnet will be attached to the shaft. The whole thing would rotate. So with a longer shaft, we can have the magnet close to the sensor like this. So the shaft will be like sticking out. Yeah, but for this we need a second controller, which I would like to avoid. Especially for Chordie, because for Chordie we have like 16 pins used. Yeah, because it's a direct connection. So I'm using, on one side I think I'm using like 17 because there's a volume knob. So we have 3 pins for the volume and 3 pins for the scroll. Well, now it might be less because we won't have the switches probably for the encoders, which is not that much of an issue with the scrolling ones, but might be an issue for the volume actually, because we won't have the mute function. Maybe we can squeeze in a small switch somewhere, like a mouse switch. Okay, how is it going? Where are we? 8 minutes left. Cool. I hope I won't break another shaft. Yeah, so other than this design with the bearing, I don't really have anything else. I mean, for the horizontal, of course, if you want to go vertical, yeah, we can either use the one from GitHub or we can conjure something ourselves. I definitely have to order the small ones, like 5mm, 7, to compare. I wasn't able to find like dowels that would be the same size. I mean, like same shape like this, like the shaft for the encoder over here, this part. So it's like 6 times 60 degrees. If I could find like a metal one like that, that would be super cool. Also, it would seem like the shaft is not really same size. Looks like it's 2.2 over here. And it's 1.75 over here. Let's take a look at the mouse. Oh, this one looks like it's a fixed size. And it fits both sides, so it doesn't look like it's smaller. Looks like it's the same size all the way. I mean, same diameter. So the only thing that is blocking the wheel is this part over here. If the shaft is this thin, it would go all the way through. Okay, let's check the print one more time. 5 minutes left. Okay, not too bad. Also makes me wonder if this won't be too tight now. I should still be able to take the bearing out of this. Well, either way, it's gonna either it's gonna stay on the bottom plate or it's gonna come off with the knob. So I think whichever is okay, then I'll be able to remove it. Oh, we also have a drawing for the shaft, how it's supposed to look like. Okay, almost done. 2 minutes left. Can't wait to take it off the build plate. I think it's finishing the shaft. It looks kind of funny because it looks like the pinhead is not moving at all. Okay, and it's done. So I'll just go pick it up. I'll be right back. Okay, so we have fresh stuff. Roda, you still there? Okay, first thing, let's try this one. So we've made this, of course, great. So we made these tiny grooves. Let's see how it fits now, if at all. Yeah, looks like it locked in, or is it just me? Yeah, seems like it's locked in. Okay, so now here comes the bearing. I'm still too loose. I don't quite understand because it should be 7.9.95. Maybe I should make it 8 and just call it a day. Well, anyway, let's put it here. We have this, we have our knob over here. It's kind of wobbly like this. Okay, let's put it all together. Okay, so now almost fail because with those openings, but actually it should be, I should be able to push it in because it's, yeah, so it kind of moves around. Okay, so it's not that bad. Okay, so there is room for improvement, definitely. So the main issue is that the bearing is kind of wobbly. It's still not, it doesn't hold well enough. So as you can see, when I rotate like this, it kind of goes up and down, up and down. Yeah, but it's kind of promising, I have to say. I think we have to make it a little bit bigger, like 32. Yeah, it's definitely it's better than this one. This one was so difficult to rotate, and this one is very soft, very easy to move. Okay, we are onto something. So there is some progress today. We have a good shaft that fits well inside the encoder. So that's a win for us. Get it? Yeah, I'm happy as well. But before we finish, let's take a look at the one with the screw, because I almost forgot about it. Okay, so that's the other one. It goes like this. Okay, but makes me wonder if the screw goes through. Most probably not. Okay, so now I can't really push the screw through because it's rotating. Okay, so I think the screw idea is a bit screwed. It's not good. I can't push it through. And we don't really want to have a screw sticking out on top. I want this part to be clean. And since we can't go through like this, and the only way is from the top, so that's not gonna fly. Okay, so we have these two for now. I will try to do some more things off stream, maybe today, maybe tomorrow, see how it goes. And I will see you on Wednesday. Not quite sure what we'll be doing on Wednesday. If I am stuck with these, and I will be waiting on more encoders, the small ones maybe, and the different bearings as well. So maybe we'll do something else. I have one project in mind that was somewhere at the back of my mind, if I can say that. Maybe we can start like a side project, but not related to the number of followers on Twitch. So maybe we can try to do something about it. Yeah, in the meantime, we'll be waiting on some more parts. Maybe I will do some more design like off stream, because I don't know if it's that much interesting doing like Ruder Brother, you're okay? Watching like the different iterations, like going over and over and over the same thing. Yeah, if you're not okay, then most of the others won't be as well, then we can do something else, and I will just push this off stream. And once I have a final design, then we can come back to it, come back to Chordie. Okay, but for today, thanks very much. Thank you for watching and for joining, for commenting on the chat. Kinda interesting. Okay, yeah, this is like a typical workflow, but I'm not quite sure if it's that much interesting when you do the same part for like over 2 hours, and it's either don't fit or it's even broken from the design perspective. So yeah, it might be boring, like looking how I struggle. Okay, but if you enjoyed it, that's fine. Maybe we will continue on the next stream on Wednesday. Maybe we'll do something else. Maybe we'll just mix up things. We'll do some parts of Chordie and maybe the side project, see how it goes. Yeah, it is prototyping, added words. You know it. Okay, so we'll continue prototyping on Wednesday. Thanks for joining. Thanks for watching. Leave a like if you liked it. Leave a dislike if you didn't like it. If you don't like prototyping, maybe I should leave a dislike because bye Ruder Brody. Thanks. Maybe I should leave a dislike because I don't like prototyping. Well, anyways, thanks for watching, and I will see you on Wednesday. Take care. Bye bye.